David Demortain. I'm a sociologist based in France, working in the area of science and technology studies and innovation studies. We have just an hour. Yes, so I'll very briefly introduce the context in which that kind of research is done in France, just sort of institutionally, so that you have you gain some familiarity with where I sort of come from. And with the sort of places you could, if you're interested, come to and visit, you're very welcome. And then dive into a research project that we've done with about 9 other colleagues from my group about anticipation in policymaking and the kind of anticipatory kind of knowledge and expertise that take roots in policymaking and governance. So innovation studies and science, technology and innovation studies in France. Very briefly, so I'm part of this research lab, this research center, LISIS, the Interdisciplinary Laboratory for Science, Innovation and Society, which is connected to the East Paris University. But what I want to introduce you to today is this consortium of research networks around in the Paris region. So about 10 years ago, some senior researchers based in those laboratories thought that there was some initiative to be had to structure research on science, technology and innovation in France and an opportunity to do that in Paris in particular. So they got together, created that institute, Institute for Research, Innovation and Society. Luckily, they got a grant, a big governmental grant that means that this group of research centers has access to about €500,000 every year to recruit postdocs, to launch new research projects, to set up various kind of events and what have you. And this has allowed us collectively to explore a few, to be on a research front. This front being the reunion of science and technology studies and innovation studies, two sort of branches, two streams of research that were not very much connected so far in France and in Europe in general. Two sort of strains of research that had their own sort of paradigms and concepts, and also their own sort of meetings to talk and exchange about their research, and very little communication. Whereas obviously 10 years ago it seemed the proponents of these IFRIS kind of institute that there was a need to apply to innovation the sort of perspective that STIS had developed to analyze science and technology, and basically approach innovation in a historical, sociological, empirical, I wrote occasionally critical way to understand how science and technology shape society and may be sort of governed. And these words, I think, resonate quite well with also the agenda of SFIS. So hence also my desire to come here and exchange with people here. So IFRIS has 4 strategic research orientations. A mouthful, but obviously you need to advertise themes quite strongly when you're looking for grants and for governmental funding. So you may visit that website if you want to know more. But basically one theme about new and plural modes of innovation, user-centered innovation, social innovation, and the ways in which transitions, so the sustainability transition, the agroecological transition in particular, are the kind of transitions we use, are sort of take shape and are governed. Changes in knowledge production regimes refer to changes in the relationship between university, industries and government, and the arrangement of these different spheres involved in the production of knowledge. We also, as part of this theme, focus on what we call knowledge-intensive organizations, such as bureaucracies employing scientific expertise and scientific data, and how they do that, and how knowledge shape these organizations, and conversely how these organizations are shaped by the knowledge they use. One theme to cover sort of global issues and the governance of global problems with a technical and scientific dimension. And last but not least, what we've called the construction of futures and techno-scientific expectations or promises. So basically, the institute funds research that falls under either of these themes, and I'm going to focus on and give you an example of what we do on the construction of futures. And the starting point here is that, as we all know, prediction is impossible or unreliable, despite what many sort of sciences offer and claim to be able to do. And therefore, when we put that ideal of prediction aside, then what empirically do we see? What are the concrete ways in which anticipatory knowledge is produced, and what kind of anticipations gain credibility? And in particular, one of the things we were interested in was in a policy context, in whatever sort of area of governance. If you take climate, if you take chemicals governance, or regulation, as I will do later. So what forms of anticipatory knowledge sort of take hold and institutionalize in one area? That's the sort of broad set of questions that we were interested in when we developed these research orientations. So then moving on to the more specific project I've led with other colleagues on prediction and modeling and prediction in public policy. It was a 4-year project funded by the French National Research Agency. The question was, is there really something like a drive and expansion of digital simulation? And the context in which, so we made our proposal, and the context that sort of led the National Research Agency to give us the money, I think was the context in which there was a lot of hype around new forms of intensive computation and a sort of revival of digital simulation, which is an old technology, but a feeling at the time that digital simulation could be used in many more areas than it was so far. So I've put images coming from the Dassault System company. You may not know it, but it's one of the biggest multinational company developing simulation softwares. It's a spin-off of the Dassault company in France that develops that makes aircrafts, and so Dassault System has developed softwares which have been very successful at Boeing or other aircraft manufacturers to design digitally those technologies and simulate the behavior of these technologies. And Dassault System claims that nowadays their simulation technologies are so reliable that the Federal Aviation Administration can register a new plane design just on the basis only of simulations, that it doesn't even need test flights, okay? But more importantly, that company about 5-10 years ago engaged in an expansion to other sectors, meaning if we can model and simulate like technical systems, like cars or planes, and we know how to do that well, we can simulate other systems like urban systems. We can also simulate other systems like biological systems. And so they've developed and they pushed their sort of software towards other industries. And they seem to be doing that more or less successfully so far, at least as far as the pharmaceutical industry is concerned. So now what we were I mean, we did not buy that discourse and that sort of software development completely, although we were, I mean, rightly, I think, well, impressed and convinced by what Dassault Systèmes was trying to do. But then we thought we need to verify whether there is such a trend towards the expansion and use of digital simulation in various areas. So we developed a project, and the idea was to go and look in 3 very different areas what kind of tools for anticipation were in place. So a very, well, a kind of difficult method design, because it's very difficult to compare those 3 areas, but kind of very powerful, because if you manage to find if commonalities emerge from the comparison, then you know that you have something quite robust. So we focused on energy systems forecasting, and so in that area you have the kind of what policymakers use, and also industries and NGOs are these kind of models where you model the energy system, all the things that go into the production and the use of energy. You parameterize, you calibrate the model, and based on that you can anticipate, you can predict the effects of certain policies, of rising certain taxes, taxing certain energy sources, and so on and so forth. Markal being the sort of the model that has become the most frequently used in that area across many sort of countries. Computational toxicology is the field in which you model the relationship between a chemical and certain toxicological effects, and by storing these relationships, these equations in a software, then you're able to simulate the toxicity of new products without actually testing them physically on animals or on humans, even less so, because it's forbidden, as you may know. And finally, predictive policing covers this sort of software and visualizations of the probability that in a given sort of territory, these are squares of 500 meters on 500 meters, a crime might occur in the next sort of hours or day or something. And it's the kind of software that has sort of spread through US cities in the past 10 years. So I'll run through, I don't have much time, and the difficulty for you will be that I won't have time to go into the details of each of these forms of anticipation, but give you some generic results coming from this research. The first basic observation, but that we made like right from the start of the project, was that prediction, forecasting, foresight, anticipation, computation, risk computation, and so on and so forth, that there was a variety of ways of talking about anticipation. There was not one common language applied in all those 3 areas. In certain instances, the same thing was designated by using different words, and sometimes the same words were meaning different things across those areas. So, and similarly, anticipatory practices in general don't look at the same time horizon at all. I mean, the future is very relative from that point of view. In energy forecasting, you're looking at effects at a sort of 1-year term or many more years term. In crime prediction, you're looking at very short-term sort of anticipation, what's happening in a week time, in a day time. And when you try to, compute the risk of a chemicals, anticipate on it without testing it, it's basically you're anticipating on effects that will be observed once the thing is on the market, which may happen again in a day or in a year or in 10 years' time. And that's important to bear in mind, because it means there is not one sort of common, you could say, epistemic community behind anticipation, pushing certain technologies and certain ways of anticipating across all areas. In those different areas, there are different disciplines, different expert networks involved. Okay, so that's one generic kind of observation that we made early on in the project, but that was confirmed by empirical research. Second, there is what we've called a market for anticipation. And in all three areas, what we've observed was that there was what you could call an oligopoly of proponents of anticipatory knowledge, okay? That over time, only a handful of models and algorithms and predictive tools were being offered, and that, well, over time there was a change in the hierarchy of these models, algorithms, and tools more broadly. So in energy, I mean, there's a succession of different kinds of models, top-down models, bottom-up models, developed by various schools. So we focused on France, and we sort of did the genealogy of different models, looking at the experts, the scientists that were behind, when and how they were used in policy making. And again, there's a sort of oligopoly, perhaps 5 to 10 models in a stable way being used. Same thing in crime, and same thing in chemicals regulation. You have a handful of private companies, often private, offering this kind of software tools for toxicity prediction. And there's a logic to that, which is that you predict or you anticipate only if you have data that allows you to construct and validate models. And the fact is that in all those three areas, you have limited amounts of data, limited amount of databases available to develop your own model, your own prediction. Basically, you have different modelers working with the same kind of databases. And therefore, competition is not completely open because everybody competes with the same set of data. And since you cannot multiply data infrastructures and curated, standardized kind of databases, therefore the competition is sort of bounded, regulated by that, if you will. The other implication is what we've called path dependency, meaning that over time there is a limited possibility for newcomers to enter into those fields and offer new kinds of predictions, so new kind of anticipatory knowledge, which is linked to obviously the investments that you need to make in infrastructures to have reliable sets of data and hence validated models. Also, something that we were surprised by was that either the modelers or the policy people using those models were all looking for sort of familiarity with those tools and those trying to gain a sense of what the tool is actually good at. How does it predict and how well does it predict certain things, and what does it not predict, and so on and so forth. And there's a slow familiarization with those tools, and that has a consequence, which is that the cost of changing to another tool and to another way of making predictions is really high, and therefore neither modelers nor policymakers would easily jump to another kind of modeling tool or algorithm. Lastly, there's strong path dependency because there are what my colleague Stefan Aykut has chosen to call predictive assemblages. In a governance area, if you look at whatever, I mean, we're talking about governance, so sort of multi-level, multi-actor kind of policy areas with policies being made at different institutional sites. And in those various sites, people have a tool that they prefer, and there's a sort of assemblage that is being made between those actors, their visions of the policy that needs to be made, of policy futures, and the kind of anticipatory knowledge that they are familiar with. And those assemblages are also quite stable over time. And because people compete in those areas of governance, they tend to stick to their tool and oppose their predictions and their anticipatory knowledge to that of others. So again, going on, commenting on changes in the way we do anticipation in various policy areas and in the ways in which anticipatory expertise takes form. One of the things that came out quite strongly was that anticipatory knowledge changes when policies change. So at the occasion of major policy shifts. And so again, looking at historically at what the tools for quantifying energy futures or crime or toxic chemicals and their risks, what you see is that the changes in the actual models or algorithms being used were happening at the occasion of major policy shifts. So on the energy side, the early 1970s and the oil shock was a big moment of change in that area. It's the moment when modelers and policymakers together realized that they were not very good at anticipating changes at the level of energy demand, okay? And that the kind of models that engineers had developed very much focused on energy supply, energy production, were not sufficient to actually anticipate what could happen in an oil-shocked kind of world. And so at this very point, you see the emergence of the so-called bottom-up models, okay, and a change in the emergence of a new generation of models, and new connections being made between modelers offering a new kind of model, a new kind of anticipation with policymakers. And the 1980s onwards, in Europe, but in the US too, obviously, is a moment when we started doing some thinking around the necessary transition towards more sustainable energy systems. And what we've seen then on the energy side was the emergence of, again, new models taking into account going back to energy sources and energy production and factoring in various kind of non-polluting energy sources and sustainable energy sources, pushed by NGOs who were actually investing, going into that policy arena, trying to push, as far as Europe was concerned, a shift away from the nuclear energy. So you see a quite strong intertwining between the ways of modeling and the policy agenda. I've put here, mentioned market steering, because why do you need models at all? And that would, in the energy area, that is related also to another kind of policy change, which is the liberalization of energy markets, as far, again, Europe was concerned. In fact, the state does not control the production of energy because it's delegated it to private companies, and therefore, instead of producing energy itself, the state would use models to be able to sort of credibly steer what private producers of energy need to do. So again, there's a shift to another policy paradigm, a sort of neoliberal policy paradigm, and that reflects in the way in which we anticipate things. So I'll go perhaps a little bit quicker on crime and chemicals, but again, you can't dissociate the rise of predictive policing kind of software from a particular context, which is the sort of broad controversy which we've seen in Europe and in the US too about the efficiency of police forces in terms of crime resolution. And also sort of controversy about the accountability of police forces for their performances. And that's a context in which police forces around the US, in Europe too, have invested into new tools to actually improve the performance of policing, control what police officers would do in the field, and steer it more closely. Again, this whole thing falls under a policy paradigm, which is new public management, so in the application of private managerial methods into public services or city kind of level services. And it's, quite clearly in that context that predictive policing tools have emerged as a replacement for the kind of statistical tools that certain police forces like CompStat had introduced before to try and measure and benchmark the efficiency of their policing kind of action. And CompStat being, and the statistical tools being accused of biasing the action of police forces in some way and being affected by sort of controversy itself, then predictive tools emerged as a new possible tool that police forces in many cities around the US have found sort of attractive and resorted to. In chemicals, you can't dissociate the drive towards modeling and prediction from the adoption of laws that aim to control vast quantities of chemicals at once. So in the US, it's the Toxic Substances Control Act of 1976. In the EU, it's a later kind of legal initiative called REACH, whereby so EU authorities have sort of wanted to assess 30,000 chemicals all at once. And therefore, if you need to assess things fast and decide fast on vast quantities of chemicals, obviously modeling tools come in quite handy. And so both in the US after TASCA and in the EU after REACH, we've seen a strong drive and a strong impetus to develop new tools for anticipation. Okay? The whole thing being informed by a paradigm of risk regulation whereby you can and you should, in fact, regulate things on the basis of what they are, or what the effects they might have in the future in human populations. So, and again, this sort of large-scale regulation thing, risk regulation, that emerged in the 2000s in Europe, and you can actually sort of fit to that timeline, the timeline of the development of new software, new models, new ways of predicting risks, and new claims to be able to predict risks. So, finally, a few remarks about futures and anticipation. If you as you heard, I sort of stressed the policy context in which those anticipatory kind of tools were introduced. And that led us to an observation, which is that perhaps paradoxically, anticipatory tools are not really used to project towards the future or to identify futures or even to construct futures, as would be the kind of aim under a foresight kind of regime and scenario kind of making regime. But anticipation and in policy is very much about getting a snapshot of the future to inform immediate and current policy choices. It's about sort of making a detour through sort of the future to actually inform policy developments now. Some authors have called that abduction of the future, and we can only sort of confirm that broad observation. And related to that, as I've just sort of hinted, what's interesting is that the methods that are most geared towards actually constructing intentionally sort of futures, different kinds of futures, have been displaced very much by sort of tools that aim to predict and define in quantitatively sort of precise manner what the future will be, to actually parameterize policies as they are made sort of now. And one last point, it's a pity that I don't have much time to develop this, but new ways of anticipating, and digital simulation, as I've mentioned at the start of this talk, are only introduced if there's a clear dissatisfaction with existing tools and existing anticipations. And in all three areas, what we've seen is that if you actually go to policy people and actors involved in the governance of an area, what you see, what predictions provoke among those people is not a competition to be a better predictor, but it's an evaluation game, meaning your prediction is whereby actors respectively deconstruct their tools, their predictions, mutually compare what their models and algorithms are, and what it can predict and what it cannot predict. Basically, there's a major issue here of knowledge evaluation. That's what kind of anticipation translates into when you look at policy, what policy actors concretely do around futures and anticipatory knowledge. And again, so new tools, new ways of anticipating, and the sort of the latest kind of predictive tools and fashions, as Dassault would promote, would only sort of make its space and take root in a policy area if previous tools have been proven collectively sort of unreliable or limited in the kind of predictions that they offer. So altogether, that shows that, again, in empirical, practical terms, the way in which anticipatory knowledge is used in policy is not by sort of imposing futures, making actors sort of project themselves towards futures, or inventing new scenarios and new policy futures, but it's really what it opens is a confrontation around the kind of knowledge that they use to impose one policy and defend one kind of policy at a given, in the present, sort of, rather than in the future. So I went over those different, again, general findings. Sorry for the express kind of summaries of each of those cases, which were really rich. And if you want to read more about this, so there's a special issue of Science and Technology Studies, which is the journal of the European Association for Science and Technology Studies. It's coming out in a month or two, and with various papers on these cases that I've presented and others. So thanks for your attention. I don't know who's the chair then, so but well, just raise your hand and we'll go about this way.
I was thinking that the actors of governance, it seems like the models are used as a way to introduce some objectivity in what is very much a subjective kind of science. I mean, predictivity has a lot of sort of subjectivity in it. So you bring these models in to bring in sort of some objective nature, bring numbers essentially, right? But the sort of actors of governance, do you think that they're using this almost as a way of providing their own confirmation bias, to sort of boost up? They think that this is what the future holds, so I'm going to take this model, I'm going to tweak it and play with it until it confirms my bias.
It's quite explicitly the case, I think, in the energy world, where, so I wouldn't say that it sort of unconsciously confirms their bias, but quite clearly, if you look at what NGOs have done since the 1980s or 1990s in Europe, is that they have sort of proactively invested in modeling to try and build, again, a sort of objective or objective and material image of the kind of policy future that they wanted to push through a model. I'm giving a representation of that policy through a model. So therefore, quite clearly there's an element of that you push a policy through a model. And the more actors do this, the more other actors will also enter the game and also try and pick the model that is best suited to demonstrating the kind of policy outcome that they favor, like getting rid of nuclear energy and promoting solar energy is a good choice, because as you will see in 20 years time the situation will be this and that and this and that. So it's a way of testing and therefore defending policy proposal. That's quite clear. However, the situation would be kind of different if you look at prediction that's based on this kind of black boxed software, where the policy actors don't necessarily control really well what the algorithm inside the software says, what's in it, and what kind of data it runs on. Okay, and so the energy example is particular in the sense that there's a lot of reflexivity and a lot of transparency at the end of the day about what goes into the models and what data they run on. And data is shared and it's public often. If you look at the other cases, the data based on which models are developed and then validated, or often not validated, are private. So you would not really know what kind of databases on which the model has been developed and run with. So that's one thing. Second, the softwares are privately developed, and so each kind of software developer has an incentive to protect a sort of trade secrecy, which is, I have an algorithm that predicts better than yours, so I'm not going to tell you exactly what my equation is, and so that context makes it very difficult for policy actors to transparently say, I'm using that software for that reason, and here is what I put into it, and so on. So they use it in a less conscious way, I guess, and less reflexive way, and less transparent way. And in those cases, I think then actors may be pushing models and predictions that sort of do things that they don't control. I mean, basically predictions that they don't really know the reliability of, and those predictions might, because they don't control how it's produced, they might just overlook it and ignore it because it doesn't confirm their preferred policy, rather than just engage with it and construct a new one. So you have different modalities of that, but clearly I think what we've seen is that there's, again, an intertwining of policy work and modeling. That's quite obvious, with collaborations being tied between policy actors and modelers over time. Just collaborations that are sort of made more difficult and sort of hampered in the chemicals and crime area by the fact that the models are not very transparent, okay, and the database is not very transparent. Okay, a long answer for a good question. Thanks.
So I don't know if you've gotten to this level of detail, but I'm curious if you've seen any evidence of what happens to the non-government actors who now have to interface with policies that are based on these tools. Do these tools, have some of them been savvy enough to find inroads into the policy process because of these tools, or do these tools largely marginalize them even more than they were before, make it difficult for them to have an impact on policy?
So our perspective on this is, so on the energy side, so my colleague has looked at a particular moment in France when a sort of national deliberation has been organized around energy kind of futures in the context of the energy transition. And that national energy transition kind of debate had, inside of it there was a sort of several days of deliberation around model predictions with NGOs and various kind of governmental actors, industries, all coming to the table with their own kind of preferred model. And with a sort of collective model running kind of exercise looking at, okay, if we choose that parameter or that parameter, if we construct the model in that manner or in that manner, what do we get as sort of outcome? So a very particular moment, because we haven't seen that sort of replicated many times in other areas and over time even in the energy area. But still, it sort of showed that the investments of NGOs into modeling made that kind of deliberation exercise possible and credible. So in fact, there's the link between so the sort of perhaps 1 or 2 decades of investments of NGOs into modeling, and the very fact of thinking that, yeah, we could organize such a deliberation, you know, and we could deliberate collectively around numbers, around scenarios for policymaking. So so there's clearly an aspect of this, that basically, yeah, modeling can in certain situations, but I mean, pluralize a policy environment. That being said, if you actually look at the moments of decisions and what kind of models informs decisions and policymakers' decisions, on the energy side, we have historical evidence of the fact that many sort of important, I mean, historical policy decisions were made leaving aside any sort of model, even the model produced by the sort of the French techno-scientific elite, you know, of which, I mean, which would have thought that, oh yeah, our models will tell the minister what to do. And so basically we have historical evidence whereby, it was the head of the national electricity company, EDF, in France in the 1970s that decided out of hand how many nuclear reactors would be constructed in the next 30 years. And he phoned the minister, and the minister said, yeah, stamped the decision and said, yeah, okay, 30 reactors sounds good. If no model, no prediction involved, even though in the background there were many models being used and so on. And so in that context, obviously, NGOs are nowhere, and the sort of the plurality of models I was talking about has absolutely no incidence, because there's a decision point where the decision maker decides sort of sovereignly, at least in that kind of energy governance, that old style of energy governance of France of the 1960s and 70s, decides kind of sovereignly what the future will be, and therefore no place for whatever sort of model. Okay. Thanks.
So my question's sort of similar to Jamie's. You've illustrated a couple of points where model choice changes because of dissatisfaction with the types of anticipations that are coming out of a particular set of models. Does the dissatisfaction, I guess, who's the one being dissatisfied, and how does that distribution of dissatisfaction manifest itself? What is it? Is it really that sort of singular top level of the hierarchy that has to be dissatisfied, or is it a broader constellation of dissatisfaction? Yeah, I've sort of simplified things when I presented that already, but there's a sort of what you could call a reputation attached to certain models and ways of predicting and predictive tools, and that reputation is forged through a succession of evaluations or trialing of the model and of its predictions, and attempt to validate it. So dissatisfaction with models emerge and matters if it's sort of, if it's a sort of collective judgment emerging in that area of governance that, no, one tool is
may be sort of good to predict that kind of thing, but will not do well for all of these other issues. So you need to look at how these evaluations take place and how the result of these evaluations circulate or don't circulate. Okay? And what's interesting is that despite the talk in those disciplines and in those sciences of reliability, validation, and so on and so forth, the results of these kind of evaluations don't travel very much, and often modelers are rather interested in sort of, well, keeping things, you know, quiet, making sure the reliability of their models or their tools is not sort of publicly sort of proclaimed, you know. And so certainly in the chemicals regulation area, what we've been able to see is that there were big stakes around what's published about models. What do we see in the academic literature when modelers sort of publish their models, publish their predictions? So how much do they put in those publications, and therefore how much do we know about their models and what they produce? Do we have the underlying data? Do we have do the modelers present both the data they used to construct the model and the other bodies of data they used to validate independently the model? Do we have the equations? Do we have, and so you have all of these criteria about model transparency to properly audit the models. And so depending on how closed or open this sort of auditing of models and prediction is, that will construct this state of dissatisfaction with models or not. So, and again, in crime control or in chemicals regulation, it's very much modelers are more like private actors trying to, well, control the circulation of judgments about their predictions. And so dissatisfaction collective dissatisfaction doesn't emerge fast, sort of, which is different again from the energy case, where there are more public comparative assessment of models and therefore some more public reputation about different models and different schools of modelers. Yep.
I have a question. In your first slide, you had the word expertise.
Right.
And where I'm going with this is, do you make the distinction within the consortium that you work with on experience? There's a difference between an expert and someone who has experience. Because if you're looking at the policy realm, you look at predictive things because you want to drive down your risk. Less risk, i.e. means less money. So when you sit down, do you take a look at the model and have somebody who has experience in the field? Because my presumption is you may be an expert in energy, crime, and chemicals, but you may not have the hands-on experience in those areas to where if you've got a modeler writing, I mean, an algorithm is just math, it's code. You know, you write your equations. Somebody with experience to review what the modelers are doing to try to give you a little bit more predictive knowledge. Did that question make sense?
Yeah, no, it makes sense. I've used expertise in a slightly different way. I mean, as to put forward the question of sort of who becomes this sort of authorized knower about the future, who out of this sort of competition to anticipate becomes the one that is sort of trusted and consulted, so therefore has the expert. So that was the idea in using that term. But then what you bring in is the question of experience. There are different ways of taking it into consideration, but certainly I would link it with what I've just developed around evaluation, auditing, or in the terminology of modelers, validating models. There is a sort of tacit way of validating models which is against the modeler's experience of things, okay? Or his accumulated sort of experiential knowledge of, let's say, toxicity of products. Let's say he's developing or she's developing a model with all sorts of parameters using data, simulating things. And I'll just finish that sentence. And just the ability to say that there is a fit between the model and reality is based on accumulated experience and observations made often in the real world. And that's a sort of a kind of, let's say, a competence that is not often, we don't talk about very often in those fields. It's almost hidden, the fact that we need sort of out of model kind of experience and observations to be able to say how good it is.
May I have a follow-up?
Yeah.
To qualify my original question. The reason why I'm asking this question is because you then put up a slide with a French company on aircraft and software. Well, here in the United States, Boeing is being sued out of Boeing right now because of Supermax, the 737 that was grounded because the modelers were the experts when they moved the engines. Nobody talked to the men and women that actually fly the planes, apparently, and our government just wanted to, put the stamp on with it, and 700 people were not killed because of it, and Boeing is going to be billions of dollars. So I'm trying to get a handle on where the experience
right.
Where that word experience actually fits into the model.
Well, it sort of fits in that story in two ways. Basically, you need experience to be able to develop a proper. I mean, experience goes into the development of models, of proper sort of robust kind of models. Out of experience, engineers would know to basically simulate properly how a plane flies. There are all these elements that we need to model, to put inside the model, and there are other elements that we don't need to put inside the model. And that comes out of often, accumulated but very much tacit experience and a sort of, practical competence of modelers. But experience comes into play in another fashion, which is, and that's something that we've been able to observe in those different policy areas, is that models are never sort of trusted at sort of face value, and decisions are often not made on models and model predictions alone, because policymakers and modelers and everybody else in those areas know all too well that we can't predict, or that the predictions might be sort of, if not biased, just miss the target. And therefore we also need, besides modeling, we need actual experiments, we need physical testing, and very much oftentimes in either of these areas, the rule is that basically models sort of assemble with other elements of knowledge and experience to make decisions. In chemicals regulation, no regulator would decide on letting a product go on the market based on a prediction alone, derived from model. And in fact, oftentimes the way models are used is by the simulations are used to design experiments. Models are used as indications of, what do we know, what don't we know, on what kind of element should we gain experience. And therefore, models are used as a sort of guide to accumulate knowledge in other ways, through experiments, through observations, and so on and so forth. So again, thanks for raising the experience dimension, because it was another element that we've seen, that, predictions only have an influence on decisions through an assemblage with other kinds of elements of knowledge. Thank you very much for your questions.